In this video, I will be going over how to write chemical formulas based off the charges that the elements have. So, if you look at the periodic table, I don't have the entire periodic table in front of me, but the main thing you need to worry about is the groups. So starting with like hydrogen, you got group 1A, 2A, 3A. Then you skip over the middle part where the transition metals are. You have 4A, 5A, 6A, 7A, and 8A. And 8A. So the groups have the number of valence electrons and charges. So group 1A has a 1+ charge, 2A has a 2+ charge, 3A a 3+ charge. 4A is blank because you're following the octet rule basically. And 4A is a little different because you're trying to get 8 valence electrons. And when you combine elements, it's harder to get 8 when you only have 4. So really group 4A can have more than like it can have different charges. So for right now, we're not gonna worry about 4A. 5A has a 3- charge because 5 + 3 is 8. 6A has a 2- charge, and then 7A has a 1- charge, and 8A is 0 because it already has 8 valence electrons. So the minuses mean it's an anion, meaning they're gaining electrons, and the pluses mean it's a cation because they lose electrons. So pretty much on a periodic table, which I don't have one in front of me right now, but on a periodic table, the metals are all on the left side. So metals lose electrons and become cations. Non-metals, which would be like oxygen, fluorine, those gain electrons. So that's why they become anions with the negative sign. So let's go over how to write chemical formulas real quick. I'm gonna skip this one for first because this is zinc is a transition metal. So let's start off with just a regular metal and non-metal. So you have to look at the charges. So you have polyatomic compounds. Like right here, you see CO3, PO4, OH, SO4. These have charges on them because they're combined. The C and the O are combined. So this would be carbonate. Carbonate has a 2- charge. PO4 is phosphate. Phosphate has a 3- charge. So again, this just means they're getting extra electrons. So in order to balance it with the octet rule, it had to get 3 more electrons for phosphate. OH is hydroxide. It has a 1- charge. So instead of just writing 1-, you could just write minus. It's the same as writing 1-. And SO4 has a 2- charge. So since I know that OH has a minus charge, I can come back over here and put minus. You see right here in group 1A, Na has a 1+ charge, so I can just put plus. And really that's it. That's how you would write that, because the plus and the minus balance out to 0. So this would be sodium hydroxide. So when it's an so that's an ionic compound, a metal and a non-metal. So when it's ionic compounds, you don't use the prefixes mono and tri and di and tetra, hepta, deca, nana. You don't use those in ionic compounds. You only use those in covalent compounds. So let's do this one. This one, well, this is covalent. This one would be nitrogen trihydride, but you just call it ammonia. CH4 would be methane. NF3 would be nitrogen. trifluoride if we wrote it out. So this would be methane, ammonia. But the main part of this video is we're about the charges, so I don't even know why I put these on here. But it would be trifluoride, then methane. All right, so let's go for the transition metals. With transition metals, they'll use Roman numerals because transition metals aren't like the other metals. They can have more than one charge. Some of them can have a 1+ charge, a 2+ charge, a 3+ charge. There are exceptions like zinc and silver, because silver has a 1+ charge, zinc has a 2+ charge, and silver has a plus charge. So let's go through some transition metals. So V is vanadium. So in order to calculate the charges, I'm gonna do, this is an easier way to do it. I'm gonna put my metal on the left and my non-metals on the right. So starting off, sulfur, if I look right here, sulfur is in group 6A, so it has a 2- charge. So I'll come up here, put 2- at the top, and it's 2 sulfurs. So 2-, so I'm gonna write 2-, 2-, add them together, that gives me 4-. So that means on the left side has to be a 4+, because we have to remember, in order to balance out the formula, they have to be 0. So 4- and 4+ to get 0, that means this vanadium has to have a charge of 4+. So, and it's only one vanadium, so only one number can give me 4+, and that'll be 4+. So this one, when I write out the name, it'll be vanadium, vanadium 4, you got to put it in parentheses, Roman numeral 4, sulfide. So remember, in an ionic compound, the second word is going to end in IDE unless it's a polyatomic. So it like carbonate, sulfate, phosphate, hydroxide. Well, hydroxide does end in IDE. But like nitrate, nitrite, sulfite, all those would end in either ATE or ITE, unless it was an acid. All right, so let's look at this one. Nickel. Nickel is Ni, then you got oxygen. Again, oxygen right here, group 6A. So this has a 2- charge, and it's 5 of them. So when I go to show my work, 2-, 2-, 2-, 2-, I'm gonna do 5 of them, 2-. Add them all together, you get 10-. So that means the left side has to be 10+, but I have 2 nickels. What 2 numbers that are the same added together will give me 10? Well, 5. So 5+, 5+. Whatever I'm writing here is going to be my answer. So this one, if I write out the chemical name, would be nickel 5, the Roman numeral 5, oxide. All right, let's do another one. I got iron and I got chlorine. Chlorine is right here in group 7A, so it has a 1- charge. So chlorine has a 1- charge, and there's 3 of them. So 1-, 1-, 1-, add them all up, you get 3-. So that means this has to be a 3+. And I only have 1 iron, so what one number is going to give me 3+? 3+. So this one would be iron 3 chloride. All right, so again, remember zinc and silver don't use Roman numerals. So let's go over here to our zinc. Zinc oxide, zinc, we already just said zinc has a 2+ charge. And if we look back at oxygen, it has a 2- charge. So this one is already balanced. It'll just be zinc oxide. Let's do these right here to end the video. All right, so Ag is silver. Silver has a plus charge. CO3 2 minus is carbonate. Carbonate has a 2 minus charge. So in order for these to balance, how many silvers will I need to get 2? Right now I have 1. I need 2. So I'm gonna actually need 2 silvers to balance this out. So the chemical formula will be Ag2, because that's indicating that I have 2 silvers, CO3. And that would be silver. The chemical name would be silver carbonate. Silver carbonate. Now, let's do this one. Pb is lead. Pb and then PO4 3 minus. PO4 3 minus is phosphate. So I have lead and I have phosphate. So I would do the same thing with my chart. I'll come up here, Pb on one side, PO4 on the other side, and it's a 3 minus charge. So for this one, this Pb is gonna have a 2 plus charge. So if I know this Pb has a 2 plus charge and 3 minus, I need to figure out, okay, what's the least common number that both of them have that I can get to make them even? So I got a 2 and I got a 3. 2 won't go into 3, 3 won't go into 2 evenly. What about 4? 2 goes into 4 evenly, but 3 doesn't go into 4. 5 is an odd number, so 2 is out. What about 6? The best way when you get stuff like this, like in math, you just multiply them together to get the least common, well, not the least common factor, but to get a factor for them. So 2 times 6 is 2 times 3 is 6. So we're looking for 6. So if I know I'm gonna need 6, I can just do 2 PO4s. So 3 minus, 3 minus. And what 3 I'm gonna need? I got 2 pluses to charge, and I need to get 6 plus, because the right side is 6 minus, so I need 6 plus over here. And I know I gotta multiply by 3. So what 3 numbers evenly add together to give me 6? Well, 2 plus, 2 plus, and 2 plus. So this, when I write out the chemical formula, would be Pb3, because I needed 3 of them. PO4 in parentheses because I need 2 of them. And the name would be lead 2 phosphate. All right, so let's do the next one. Calcium is, you can't see it, but calcium is in group 2A. It would be right here because this is potassium. Calcium would be in group 2A, so it has a 2 plus charge. Oxide has a 1 minus charge. So in order to balance these out, I would need 2 hydroxides. So put in the parentheses, put a 2. I have to put it in parentheses because if I just put a 2 behind the H, that means the 2 would only be allocated to the H. But if I put it in parentheses, the 2 goes with both the O and the H. So the name for this would be calcium hydroxide. All right, last one. So we got silver again. Remember, silver has a plus charge and it's SO4 2 minus. So again, I'm gonna need 2, it's just like the carbonate right here. I'm gonna need 2 silvers to balance with the sulfate. So it'd be Ag2SO4 and the name would be silver sulfate. So for those who may be struggling with writing the chemical formulas or writing the chemical names, I hope this video helped a lot. And make sure to check out my other videos on science. I'll have more videos coming soon. Subscribe to the channel, like and comment. Trey T out. Peace.